So a correlation is measuring how closely two variables are related to one another. We can have correlations for multiple variables too, but in this class we just do two. And in this class we only talk about linear correlations. If you have a scatter plot and the dots end up looking like this looks like a correlation coefficient of -1, which means 1 is a perfectly straight line, and the negative sign means it's going down as you read it from left to right. Okay, so you got to read it left to right like you read it a book. If it's going down, then it's negatively correlated. A correlation of 1 looks like this, dot, 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 dot. It's a perfect straight line, and it's going up. Because if you read it from left to right, the dots are increasing. It's perfectly correlated. There is no error if it's perfectly 1. In practice, you might get some really close dots, but there's a little bit of scatter. This would be R 0.8 or something like that. That's a positive correlation, but it's not perfect. If it's equal to 1, it's a perfect correlation. Okay, I got a scatter plot here. Sometimes it's called a scattergram. I don't know why. Is it strong or weak, or is it positive or negative? So this is going down as you read it from left to right. So it's negative. And the only option there is for a negative is here. Strong and weak are relative terms. It depends on the data. If this is data about like human opinion, I'd say this is strongly negative. If this is data about the percent solution of some sort of chemical, I'd say this is weakly correlated, because something like chemicals is usually easily controlled by humans. Something like a human's opinion is always going to have some sort of scatter. So it depends on the situation. But this is negative because it's going down.